Hello. Now let's consider absolute function and some inequalities. We will take help of a number line to show the relationship between our absolute function and inequalities. Okay, so the common thread which is going to bind the two things is going to be our number line. So the question here basically is express using absolute notation. Okay. Now we'll see how we can have inequalities as well as number line and absolute notation all at one time. Let us say that you want to express this particular inequality, that x is between -5 and +5. On a number line, I can show it as something like this. Let's say use like this. X is between, I'm assuming this to be 0, -5 and +5, where both are included. When we say this, that means x is greater than equal to -5 and less than equal to -5, then we fill this up. If we fill this up, that means it is included. Okay. Now, on a number line, we will represent this inequality like this. How are we going to represent this as an absolute function? Well, as an absolute function, if I write absolute x is less than equal to 5, does it represent the same thing? It does. How? Let's consider this point, center. When we say absolute x is less than equal to 5, then we are saying that everything is at the most 5 distance away or within the radius of 5, not sign. -5 is also what? 5 when you do absolute of that. So within this region. So that means yes, it goes with the definition of absolute function. And this is what we are calling it absolute notation. We are using absolute x to represent our inequality. How about this? Let me write this time a different kind. That x is less than -2 and x is greater than +2. Now, if you see our number line, again, let me show you on the number line what I'm trying to say. So what I'm trying to say is, let this be -2. So we want to be a less than, means this side. Well, I've said less than, not equal to, so I should make a hole here and not fill it up. And here, let's say this is my origin, 0, and here is my point, 2 plus, and x is greater than 2. So we get on number line, we can represent this inequality like this, where everything in the domain of real numbers but less than -2 and greater than 2. How can you represent this as an absolute function? So we say our absolute function is actually greater than 2, right? Greater than 2. Does it work? If I write -1 here, so -1 will become 1. 1 is not greater than 2. Well, it is not greater than 2. It's not here. But if I write -3, -3 will be +3. And you know 3 is greater than 2. So that satisfies our equation. So this inequality can be represented like x greater than 2. Now let's think like this. Let's do some more. Similar fashion. But now this time let me start with a number line. Now in a number line, I'm trying to say that x is everything but not 0. Everything but not 0. Tell me, how will you represent this as an absolute function? That's kind of tricky, right? Everything but not 0. Well, think about it. We can write absolute x is not equal to 0. It makes sense. Everything but not 0. Is that okay? Well, let me use different notation for this time. I will use set notation. We say x belongs to real number, but x is not equal to 0. Does it work? Yes, it does. So these are different ways of representing similar things. And especially when we are talking about domain and range, then this is a very, very effective way of using absolute function, or sometimes number line, set, or inequalities. So these are very, very different ways of representing same thing. Okay, let me take few more examples with you. If we have this number line and we want to say that we are interested in everything but 5 or minus 5. Let's say this is 5. So our domain is everything but not 5. How can you represent this as an absolute function? Well, the center value here is 0. We can say absolute x is not equal to 5. Does it make sense? Yes. So because if I write minus 5, it will become 5. So it is not equal to 5. It works. And in our set form, we can say x belongs to real number, but x is not equal to plus and minus 5. Simple as that. That is perfect. Now, if you have to represent the whole line, what I'm trying to say is everything, that is, x belongs to real numbers. How will you write that as an absolute notation? Well, there are two ways, many ways to do it. One, absolute function is always positive. So you can say absolute x is greater than minus 1. It is always true, right? It's always greater than minus 1. So all real numbers. Or you can say absolute x is greater than or equal to 0, which it is. That means all real numbers. Correct? Perfect. Now, if you have to say there's nothing on a number line, nothing, that means 0. So the domain is a blank set. Then how will you write this? Can you tell me? How about this? Absolute x less than minus 1. It can't be less than minus 1, so nothing. It is not true for any real number. And therefore, there is not even a single point on our line which will satisfy this particular condition. These were very simple, not difficult at all. Now, let's get into some tricky ones. Here is the first one. Let's say this is our number line. And this time we say that we want our function to have values within 2 but not symmetric values. What I'm trying to say is this is our 0. Normally we take them symmetric, right? But let's think like this. Let's say this is my minus 6 and this position is 4. And we want all the numbers between minus 6 and 4 to be represented as an absolute function. How will you do that? This is what we need to do. What I'm trying to say is I'm looking for a solution of an inequality which says like this, that it is x is between minus 6 and 4. How will I write this as an absolute function? Well, let's go back to the absolute definition. That is, we need a point right in the center and see how far away we are from the ends. Those points are included. You remember being close to a school, Alexander Lincoln. Let's do that. It may help us. So what is the midpoint? So we say minus 6 plus 4 divided by 2. Minus 6 plus 4 is minus 2. Minus 2 divided by 2 is minus 1. So minus 1 happens to be in the center. Let's say this is my minus 1. Okay. Now absolute function should have center here at minus 1. How far are you away from 4? From minus 1, 4 is 5 units away. How about minus 6? It is away by 5 units. That's the basic definition of absolute function. But what happened to our function? We shifted it left by 1 unit so that now the vertex is at minus 1. So I can write this function as absolute x plus 1, and we want to be within this range, not including those points, less than 5. Does it work? Think about it. It does work. So if I take a value, let's say minus 6. So minus 6 plus 1 is minus 5, and absolute value is 5, but it's not less than, right? So it's not included. It works. So that is how you have to solve inequalities with number line. Let me go the other route, and that is I'll write an inequality now and you give me the solution. If I write x minus 3 is less than 10, can you draw me the number line, show it on the number line, or can you tell me what the inequality should be? Well, let's look into it. This means what? X minus 3, that means you move 3 units to the right. There is your center. And from there, you are within 10 units away. So 3 plus 10 is what? 13. And here, 3 minus 10. What is 3 minus 10? Minus 7. So I think the inequality should be what? X is greater than minus 7 and less than 13. That should be the answer. Do you think it's right? Well, let's follow the last method. What is the midpoint of this? Minus 7 plus 13 divided by 2, which is how much? So, and then we get the center point. Okay? And after the center point, see how far are we from 13 or 7. Do you understand? So you move 3 units away, and then you want to be within 10 region. Do you understand? So you get this. Does it make sense to you? I guess it does. So some more questions for you to try. How about this? Let's say we have a number line and I want you to write both absolute function notation and the inequality for this point, which is at minus 3. So what should be my inequality, which says the answer is this, just this point, just this point. So that will be your homework, and then see if you can do it. Okay? Try it out. Let's take this example, one more example, once again, just to clarify these points. Let us say we have an inequality x plus 2 greater than 3. It means what? It means that if I have a line here, this is my 0, and if I move my function 2 units to negative, then I am considering all the points which are away at least 3 units. So 3 units from here will be at 1, right? And this side will be minus 2, minus 3, minus 5, correct? So what I am looking for, we want this distance to be more than 3. That means that is our solution. Do you get it? So this is our question number 1 and this is question number 2. For this, write this function in inequality form. Correct? So today we learned how to write your function in absolute notation, how to represent it in the form of inequalities, and how to represent it on a number line. This is a very important exercise and you will need it to write domain and range of functions and many other applications. And especially you will appreciate this when you do inequalities in details. Okay? I think you understand the use of an absolute function and its notation in this lecture. Thank you.